Hello, I am Shane Brinkman Davis Delamore, and this is Code and Optimism, a show where we explore how to solve problems faster with software. Today we're going to continue our series of talking about generative AI and ChatGPT and stable diffusion and all that goodness. And the last couple of episodes, which we'll have links for, have been talking about the broad implications whenever technology increases our productivity dramatically. What does that mean for the human equation, for the economy, and all those aspects? So if you're interested in that aspect, please jump to those earlier conversations. Today, I want to dive a bit more into generative AI specifically. The last two episodes were more general about technology advancements. I want to dive into what I would call the essence of generative AI. My first blog, Essence and Artifact, was really focused on this concept. I think that you really need to understand the essential nature of things before you can master them, before you can understand where they're going to go, before you can understand what's possible. And this kind of corresponds with Elon Musk's perspective of first principles, software engineering, or just engineering in general. I want to look at the first principles. I want to look at the essence of generative AI. So before we dive into that just a little bit, I just want to capture just the sort of the concrete aspects of generative AI just to get everybody up to speed. I'm also going to link some good references I found on the internet that are just a little bit more than the shallow cursory thing you're going to get if you just Google, and a little bit short of taking a college course on it. They're sort of in the middle. So if you are a reasonably skilled software engineer, you'll be able to understand what's going on from these resources. So generative AI, broadly speaking, we know that it's using machine learning, which today's is almost synonymous with neural networks. And generative AI is a set of weights for basically a bunch of matrix calculations in a neural network that have been trained on existing data to mostly, when in the case of like ChatGPT, it's just predicting the next word given a sequence of words. That's what it's training on. And it's been trained on the internet, broadly speaking, from 2021. GPT-3 is trained from data in 2021. And it's just trying to predict the next word in a way that makes the most sense. And it's just doing that based upon all the data it's been able to get off the internet. Now, I'll just mention we haven't looked too much at the image generators, but the image generators are also super interesting, which again, there'll be a link down below if you want to dive into exactly how image generators do what they do at a little bit more depth than you're getting on your first Google query. But it is actually a tool that can take a slightly noisy image and make it slightly less noisy combined with your textual hint. And then what the tool does is it starts from a completely noisy picture with your textual hint, makes it slightly less noisy, and then makes it slightly less noisy over and over again. And again, it just trains on real world data out there, just real pictures with their descriptions. And it trains by putting various levels of noise into the image and trains on telling the network to go from noise to a little bit less noise. And it does it at all levels, from slightly noisy, slightly low, almost no noise, to lots of noise. And so that's what it's doing. So it's just this sort of like predicting the next thing. And it's just doing it based on the patterns that it is finding in all this real world data. So I'm going to go back and we're going to focus a bit more on ChatGPT because I am particularly interested in that from the point of view of software engineering and how we're going to use it to accelerate our ability to solve problems faster. And so that was just the sort of the high level. The sequence of generating the next word, as you know, can be used for creating actual software code because it's basically generating a token. And what do? We express our software code as a series of tokens. So it's doing that same thing. You can give a little bit of English description and it will generate, a sequence of tokens that matches that it will work in the programming language. And it's cool that it works so far in that. So that's sort of the baseline. Now I want to dive a little bit into sort of the essence of that. So, all right, so it can predict the next token. What does that mean? What does that mean? And there's all kinds of speculation all over the place. So I'm going to try to do my best to capture some things that are incontroversial, that put some boundaries around this thing, which is generative AI. And to be clear, not to say that AI can't go beyond this. What I'm saying is that what we understand to be generative AI, this very specific concept of AI, will need to become something different to be able to go beyond these limitations I'm going to talk about. So I'm really talking about these limitations of this concept of generating the next token, or generating a slightly less noisy image from a noisy image. These sort of like find the next thing in the sequence, that generating the next thing in the sequence, which is what all this generative AI is doing. I think that we will come up with new ideas that are different from generate the next thing in this sequence, which will get us a step beyond these limitations I'm going to talk about today. But I think it's really important to understand the limitations of the current systems. And that will both maybe give some people a sigh of relief that there's things they can't do. And maybe will also give people a sense of, well, if you know what they can't do, you know better what they are really good at. So you can leverage them, which is what I'm most interested in, how we're going to leverage these tools. So, 3 things to talk about today. 1 is remixing. 2 is what kind of thought experiments can we use to think about this software, this tool. And last, we're going to kind of level up those thought experiments to imagine if GPT-3, if ChatGPT was perfect. Imagine if it was infinitely perfect, like it did its job exactly perfectly all the time. What could perfection mean in a concrete reality? And what is that? That's where we're going to really dive into what the limitations could be. So let's start at the top. So remixing. I think the best way to think about GPT or the image generators, the stable diffusions, is, yes, it's giving you the next thing in a sequence. That is what it's technically doing. But I think it's better to think of it as a remixing tool. It is not a tool that generates 100% novel stuff. What it does is it gives you a super powerful way of remixing the existing knowledge. And so I have some questions around that. But keep in mind that these are trained on existing knowledge, on existing photos and existing stuff out there. And it is allowing you to take that and now remix it with like this sort of infinite palette into new things. But you still have to direct the remixing. So this broad question, can these generative models be original? And I'm sure I'm not the only person asking this question. And what does original mean? What originality can they do if they can do original? Because what does it mean to be original? That's a huge concept with many different facets. And here's sort of what I'm landing on, thinking about this. This is sort of an analogy. I don't know if it's the right one, but it's working for me so far. Imagine the training data, which you can sort of think of as the internet, which you can kind of think of as a significant slice of all human knowledge, at least all like written down book human knowledge. And taking that and imagining that that is a map, a 2D map. And my analogy is like exploring a new continent. But imagine, or exploring an existing continent. Imagine you've got a map and all of the knowledge is all these points on this 2D map. And we've got lots of connections between these, like links between web pages or just using the same words. There's lots of, or just sequences of words being the same. There's lots of ways all these concepts interconnect with each other in this map, a graph, if you will. But I'm just visualizing it as a 2D map for simplicity. This map inherently has a border. It's what we would call the boundaries of human knowledge. We've used that phrase before. And so ChatGPT is learning this massive stuff within the boundaries of human knowledge. And what ChatGPT is good at is remixing is we can pick 2 points in this map with the words that we prompt it with, or 5 points. Each word we prompt it with and the sequence are points in this map. And then it can give us a new point somewhere within this map. And that point may be a place never visited before. Even though we cover a territory, the territory is infinite internally. You can subdivide it just like you can always divide a number by 2 and get a new number. So there's space within this that we can go in more depth. And ChatGPT allows us to narrow in points that have not been filled in on this map with our prompts. And will it give us something original? I think yes. I think there is originality within the boundaries of human knowledge. There's sort of like diving in deeper with what we already know, finding new intersections of ideas that is relevant, that gives us deeper understanding of the universe. What I think ChatGPT and tools like this, the generate the next token in the sequence trained on existing knowledge tools, whatever the technology ends up being down the road, I think they are going to have some limitations going beyond the boundaries of human knowledge. They don't have the tools, I think, to push the boundaries of human knowledge. And I want to qualify this carefully, because I think they can help in that effort of pushing our boundaries of human knowledge, because they're going to generate new knowledge within the boundaries, and that's going to give us more pillars to we as humans to push beyond the boundaries. But I don't think that you're going to put a prompt in to these tools and you're ever going to get a result that's outside of the boundaries of human knowledge. So that's the analogy I want to put in your brain. It's remixing. If you've got 3 points and you pick those 3 points and you try to say, give me something based on those 3 points. Well, it's a triangle. If you've ever seen the Sierpinski gasket, you might visualize it this way. The computer can jump you to any point within those boundaries of those triangles, but there's no way to average those 3 points and get outside of that triangle. So it's sort of the same thing. When we get outside, it's because we're going to push, we as an external force are going to prompt ChatGPT beyond it. Actually, again, I think that the results, it's always going to give us something that's back within the boundaries of human knowledge. But I do think that will help us. I do think that's going to give us the leverage to push the boundaries of human knowledge. But I don't think you're going to get something outside of the boundaries of human knowledge within a prompt. So, second thing I want to do is some thought experiments. That was an analogy, a little different from a thought experiment. And I got 2 thought experiments for you to help consider the essence of ChatGPT. And the first one is Star Trek: The Next Generation. I loved watching that show growing up, and they explored this concept quite a bit. Every time ChatGPT comes up, I hear Majel Barrett's voice in my head of the computer on the Enterprise responding to prompts and periodically saying it can't answer that, which ChatGPT does very nicely. In fact, it's almost the most impressive responses I get from ChatGPT is when it very gracefully says it can't do that. Like I asked it to write me an operating system, and it says, "I'm sorry, I can't do that. That's a really complicated task. It takes lots of engineers to do that." But the main analogy, and I might even just go back and rewatch some of the Star Trek episodes about the holodeck. So when our characters go into the holodeck and they ask the computer to generate a holodeck program for them, I think that's super similar to as we're thinking about using ChatGPT. We can give it some amount of prompts, and the computer is going to make a guess. It's going to take those points within human knowledge and try to find a new point that best balances those all out and somewhere in the middle of this human knowledge, and it will fill in the details and give us a holodeck program that makes some sense within those points. But the key thing here is, and I guess we'll get to this in just a little bit more, often either the computer can guess wrong no matter how good you prompt it, or it doesn't have enough detail in a simple prompt to really fill in the details. And so I think that's a useful thought experiment is, how do you just have a conversation with a computer to describe generating a 3D space? And if that computer was perfect and could answer everything, still, how well is it going to be able to intuit what you want in a way that makes sense? Because you could have 2 humans have the same prompt and mean something different. That's critical. All right. The other thought experiment I want to throw out there is there is some concern that maybe ChatGPT will help elevate senior engineers, people who are sort of on the architect level, people who are at the product level, who can kind of conceptualize, here's how we might solve this conceptually. Now we're going to ask ChatGPT to fill in the details. But more junior engineers are not going to have any work anymore, right? And of course, see my 2 previous episodes on this. I don't think it's going to be true, but here's sort of why. Imagine what a new college curriculum might look like if you rewrote it from scratch right now using ChatGPT. What does it look like for someone who doesn't know anything about software? How would you start training them right now with ChatGPT? There is going to be a new path for junior people coming in, and ChatGPT is going to help them along their way. Of course, there's going to be work for any junior people. They're just going to be able to do more and better than they could before. And they're going to have interesting follies and slip-ups that might be kind of different than the follies and slip-ups we cut our teeth in, the people who learned software engineering 10 or 20 years ago. Because ChatGPT is notorious for slipping in really weird errors that are subtle and not obvious. Sometimes they're blatantly obvious, sometimes they aren't. So I think that I think there will be classes ultimately that are sort of more like architect classes for first or second year freshmen. and they'll use a ChatGPT system to fill in a lot of the details. This will allow those junior people to try out a bunch of different architectures, see how they work when they're implemented, see what happens when they give them different prompts and reconfigure them, and they'll be able to gain a lot of the insights that it took those of us who have been working in computer for 10, 20, 30 years, or people older than me who've been working even longer, cut our teeth the hard way by doing those actual projects, coding every single token, and then seeing the results in the real world. We're just going to give these junior engineers a little bit of a leg up so that they can experiment with different architectures faster. And they're going to get those insights better so they don't make those junior engineer mistakes as often. That's awesome. Super excited about that. So those are my 2 thought experiments. Last thing on the things I want to talk about today is, let's imagine ChatGPT was perfect. And this is where I think we really get into the limitations. And I've sort of hinted a little bit at it so far, but we're going to dive into this now very explicitly. So the first thing I've already said multiple times is I don't think it's going to give us, we're going to give it 3 or 4 points or 5 points or 10 points or 100 points or 1,000 points, whatever we're going to do. Those are a bunch of words in our prompt. It's going to still give us an answer within the boundaries of human knowledge. It's not going to give us an answer outside the boundaries of human knowledge. So that's a limitation. But within that limitation, it's very interesting to me because I do think there's infinite, again, these are points in space is my visualization. And you can infinitely subdivide space. So a finite number of points will never fill a volume, even fill a 2D map, right? You can keep adding a finite number of points. You can multiply it by 1 million, 1 billion, 1 trillion, and you still will not fill that. There's always more depth there, even within a border. And I think that's what ChatGPT can help us with, which is super interesting. But even within that, I wonder, within just the existing points, without adding new points of data, new points of knowledge, will ChatGPT ever master human knowledge? And this is, I think, an interesting open question. So this is a bit of a conjecture. So one of the things that the computer file episode that I'm linking to on ChatGPT-3 talks about is, and I believe this is in the paper on GPT-3, that GPT-3, which is what ChatGPT is based on, it is learning how to do addition. And so if you add 2 3-digit numbers, you ask, say, what is, you pick a 3-digit plus another 3-digit number, 99% of the time it gets the right answer. Embarrassingly, since that's actually pretty trivial to do, it doesn't get it 100% of the time. But it did not have every single example of 3 digits plus 3 digits in its training set. I mean, that's already 1 million examples, right? It's 1,000 by 1,000. And it's learning how to infer addition given a much more limited, sparse segment of those examples. And of course, you do 4-digit by 4-digit or 10-digit by 10-digit, all of a sudden there's no way that it could train on all the examples. It has to infer. So it is learning math from these examples. And at least the video I was watching was like, oh, this is really impressive. This is cool. This is sort of an insight into its inference. It is also a little bit sad that just 3 digits plus 3 digits it hasn't learned yet. One perceptron, one node of that graph could solve this problem of the 180 billion weights is how big GPT-3 is. Just one of those 180 billion could solve all 3-digit math. So in another case, it's a little bit embarrassing, but my point is it is, in a certain sense, learning. It's inferring from a small set of data that knowledge of what addition actually is. So will it ever master it? The really interesting thing about GPT at the moment is that, and again, this computer file video on GPT-3 really goes into this, every time they make the network bigger from GPT-2 to GPT-3, it keeps getting better. They don't have to change the technology significantly. That's the key thing. And at GPT-3, they're still seeing that as they make it a little bit bigger, it's getting a little bit better. So you can bet GPT-4 is being trained right now, which is going to be, 10 times bigger. It's going to be 1 trillion weights. I don't know. But right now, it's not so much as innovative new technology. It's actually just about how can we get more compute and make it bigger. So how far will this take us? I don't know. I think it's interesting. I don't have a good answer there. But will it master human knowledge? And what will that even mean to master human knowledge? But I think that's an interesting question. Regardless of its ability to create original new knowledge, how well will it be able to master existing knowledge? And I actually think there's going to be limitations, to be fair. I don't think it will master human knowledge, but what its limitations end up being is going to be very interesting to me. All right, so next one. And this is sort of, I think, the key one, which goes a little bit back to the holodeck thought experiment. When you prompt ChatGPT, I need to add a new one. We're going to talk about another one that's not on my list right here. When you prompt ChatGPT and you're going to give it some set of words and it's going to guess a response. Well, really what we want is it to fill in the details. It's like, tell me how the dinosaurs walked since they were so big. And it can guess and fill in the details. It can pull stuff from it's seen on the internet, all those sort of things. And you might even ask it, imagine a new dinosaur with 6 legs. How well would it compete in the the prehistoric Jurassic times? But just saying it had 6 legs, there's actually a lot of different ways you might build a body with 6 legs. There's sort of the insect way. There's sort of the more, there's the exoskeleton, endoskeleton. There's lots of different ways, right? And so the ChatGPT is just going to pick whatever is best, whatever it just lands on happens to get best for the next word, and then the next word, and then the next word. There's a certain amount of information density in your prompt. And like I said earlier, even if 2 different people might have the same prompt and want different results. And so no matter how good perfect ChatGPT is, you're going to have a considerable conversation to build something interesting with it, because you have to still fill in all the details. All those details about what you want to build is going to take a lot of time and a lot of communication, even if it's perfect at filling in all the details. So there's this question of the information density of English. How precisely can you express? And I think the next big level up, I think, of ChatGPT is going to be context, having it get to know you and how you want to express things, which is really just a history of all your prompts, really. But having it actually use that information, all of the history of all your prompts, to further inform the next prompt, because it can start to anticipate how you like to ask and what details how you like the details filled in. But even once it has that context, it's still going to need a lot of details to really precisely build something of any scope. So when I asked it to build an operating system, there are, easily millions of decisions that need to be made to decide what kind of operating system. But on the other hand, it could make a reasonable first guess and get us somewhere in the ballpark, and then we can tweak and refine. But that's going to be a limitation. There's only so much you can express in a sequence of words, and there's only so much it can understand from that sequence. You're going to have to keep adding more words in order to get it more precise. Last, and I'm going to tie this to the lean startup principle. I'm sure there's lots of different ways to express this, but that's how I think about a lot of my day job, is consulting with people who need to build their first version of a piece of software. Even if we prompt ChatGPT perfectly, we have got a great prompt that's very precise, has enough detail, and ChatGPT is perfect, and it gives us back the best answer it possibly could from that response, and the result will still be wrong. It'll be terrible. I mean, terrible is probably not true, but it will definitely be wrong, like obviously wrong, as soon as you get users using it. That is because we cannot fully anticipate how users are going to use something ever. This is something I'm constantly coaching and consulting with new companies trying to make new software, is that you don't actually, no matter how well you think you understand the problem, until you've built the piece of software and started using it. In particular, it's usually not you, it's someone else started using it. You will not know all the boundaries of the requirements. You have to get it in the hands of people. You have to test it in the real world in order to actually understand it. And so not only are we going to have a conversation with ChatGPT, perfect ChatGPT, that whole process is then going to have a conversation with the real world in terms of iterative releasing, learning from what's going on in the real world, implementing, improving. And it might be a combination of your users giving you effectively prompts you're going to feed back into ChatGPT, but you as the entrepreneur or the entrepreneurial team filtering that, because you also have a vision of where you want to go. The users have a vision of what they want to do with it. You've got a vision of where you want to go. ChatGPT wants to satisfy all these needs. There's going to be still a whole lot of conversation here to iterate through things. So no solution is correct on the first try. You've got to iterate. So those are the things I kind of wanted to focus on today, thinking about the essence of ChatGPT and its limitations and its capabilities. Again, I think this applies to all generative AI. We were not focusing as much on the image generation end of things, but the same concepts generally apply. The concept being, fundamentally, GPT is a remixing tool. It is going to give you results of blending the colors of human knowledge. And we're going to give it different colors, and it's going to give us a blend, but it's not going to give us a whole new color because it's going to fill in. We give them the points we give it. It's going to pick some point that's within those points we gave it. Secondly, one of the most useful ways to think about this tool is through these thought experiments. Imagining using the Star Trek scenario. They've got lots of little scenarios of holodeck training. We can go look on YouTube and so forth. But that's a really good thought experiment to think about. Well, if the computer responded perfectly, how would I talk to it? How much do I have to tell it before it be precise? What kind of mistakes might it make that would be perfectly reasonable? Like if you imagine it was a human responding to your prompts, but that human had basically infinite time to provide the result, it would still going to make mistakes because it can't know everything that you're prompting based on 10 words. The other one is, what is a new curriculum going to look like for new engineers? And one of the things that might look like is we're going to be training engineers on architecture much earlier because now they can experiment with architecture. Before, to experiment with architecture, you had to go write 10 to 100,000 lines of code each architecture to see how it actually pans out. And you also need to run it and other things. But now, if ChatGPT can write those 10 to 100,000 lines of code to implement an architecture, you can try it out and then try out another one and then try out another one. I think it's going to be very interesting how we train software engineers in the future. It does not mean that junior engineers are going to be irrelevant. We're going to power them up and they're going to be even more awesome. And the last set of things is talking about the limitations of perfect GPT. It is going to be somewhat confined by the boundaries of human knowledge. It is probably going to not master everything of human knowledge, but I think that's the part that I'm most unsure about, exactly what it will and won't master. There's limitations to how much we can prompt. Two different people can mean the same thing. So communication, which is the most difficult thing between humans, is still going to be the most difficult thing between humans and ChatGPT. It's going to be about the communication problems of communicating what you need to the software. And at the end of the day, even if we communicate perfectly and it generates perfectly, we need to validate against the real world, and that adds another loop of iteration. And that's what the future is going to start to look like. So that's where I'm going to leave this conversation. Next week, we're going to kind of wrap up this high-level generative AI exploration we've been doing, talk about some practical recommendations I've come up with over the past couple months after ChatGPT has come out for how to think about our careers, our paths as humans through life, trying to create value and possibly using ChatGPT. Maybe it's not relevant to us, maybe not using it, but if we're going to use it, how are we going to stay relevant? How are we going to use it? How are we going to leverage it going forward? And this is going to be sort of the high level at the abstract level. I do plan to sort of drop nuggets throughout the year of things I just discover along the way. Because right now, concretely how to use ChatGPT, I think is a bit of an open question. I'm finding little ways to find it useful, but so far it hasn't written much code that I've found useful myself. I just think we're not quite there yet. But in abstract, I can give some guidelines, and that's going to be next week. So once again, thank you so much for spending your valuable time with me. This is a big open question. I would really love feedback on what you think the limitations are of ChatGPT and what you think, what will perfect ChatGPT in principle be capable of? We'll never have perfect, but when it sort of tops out and it stops getting better each time we make it bigger, what will that look like? I would love some comments in the comment section. I'd like to have a conversation around that. Do my limitations make sense to you? Or do you think you want to shoot some holes in them? Did I miss something? Because I certainly could. I do not know everything. I don't have all the answers. But I will leave you with my standard reminder because I think it's so very important. Remember that all problems are solvable with enough knowledge.